Hi everyone. In the last video we discussed up to the divisibility rules, right? So this is part 2. So the continuation of the number system part 1 video, right? So there we discussed up to divisibility rules. So now we are going to discuss briefly about three things. So about fractions, okay, and next so after the fractions immediately we can discuss about LCM and HCF. So meanwhile we will discuss about decimals also. So related, right? Fraction and decimal. So these three simply we will discuss. Okay. So let us see what is meant by a fraction. So what is a fraction definition? When we will use the word fraction, like, so fraction, it is a part of a whole. So it is a part from a whole. Suppose there is a full cake. You want to distribute between two friends. So how we can share equally? So we have to divide into two equal parts, right? So for the first person half, for the second person half, right? This half we are representing like 1 by 2, right? Half we are representing as 1 by 2. So it is a part from the whole. Suppose the same thing you want to divide between 3 person equally. So there also again we have to divide into 3 equal parts, right? So the whole part is divided into 3 equal parts. So each one will get 1 by 3. So each one will get 1 by 3. So here the person who is getting, like, out of the total he is getting only 1/3 part. So 1/3 part he is getting. So this fraction, it is a part of a whole from the whole. Whole is nothing but total. So it is a part of a whole, right? So we are reading it as half. For 1 by 2 we are reading as half. So for 1/3 we are reading as 1 by 3, right? Generally in this part, in the fraction, the first one we will call it as numerator. What it is? Numerator. And the second, like, this is a fraction, we have to use the symbol between the numerator and denominator, right? So fraction contains two parts, numerator and denominator, right? Now, so every time we can't observe the same thing, right? Suppose the same, sometimes, like, there are there are 3 chocolates, right? But only 2 persons are there. So 3 chocolates are there, 2 persons has to distribute equally. So there, how can we distribute equally? So out of 3 chocolates, 2 persons are there. So each one will get 1 and 1. And remaining 1 chocolate, what they have to do? That one they have to divide into equally. Like first person half, second person half. So 1 and half. So each person will get 1 and half. So every time we can't observe this type of fraction. Sometimes we'll get 1 and half. So sometimes they will get more. So here, based on the numerator and denominator, we can notice different types of fractions. We can notice different types of fractions. See, let us see what are the different types of fractions. So just we started with the first one, right? Half. So there we notice 1 by 2, right? Sometimes we'll get 2 by 3 or 7 by 10, like this. So what we can notice here, when you observe the numerator and denominator, numerator is smaller than denominator. Numerator is smaller than denominator. This type of fraction is called like fraction. Sorry. This type of fraction is called proper fractions. So this type of fraction is called proper fraction. So what we can notice, numerator is less than denominator. If the numerator is greater than the denominator, like 3 by 2, 4 by 3, 7 by 5, like this, then in that case numerator is greater than denominator. Numerator is greater than denominator. Then that type of fraction is called as improper fraction. What it is? Improper fraction. So proper fraction means numerator is less than. Improper means numerator is greater than. And next, third thing. So just now we observed 1 and half, 2 and half, or like 3 and 4 by 3, some 3 and 2 by 3. So a whole number and a fraction. Like this one, this type of fractions are called mixed fractions. This type of fractions are called mixed fraction. So mixed fraction contains a whole part. So one full number and remaining half. So this one we will call it as a whole part. And this So whole number and this fraction must be a proper fraction. So here we observe that 1 by 2, 2 and 1 by 2, 2 by 3. So this type of fractions are called proper. So this is about 3 types. So proper, improper and mixed. Okay. And next. So what are like fractions? Fourth one. In the different types, the another one is like fraction. What is meant by like fraction? So that for the like fraction, see 1 by 2, like 2 by 3, 4 by 3, 7 by 3, 17 by 3, so on. So what we can notice? For all the like fractions, the denominators are same. The denominators are same. Like another number, suppose 10 by 100, 12 by 100, so on. So like fractions means we can notice simply the denominators are same. The denominators are same means we call it as a like fraction. If the denominators are different, then those fractions are called unlike fractions. So unlike fractions example, some 2 by 5 and some 7 by 10. Like 70. Here if we notice 2 by 5 and 7 by 10, here we can notice the denominators are different, so we can say unlike fractions. But these fraction also we can convert into like fraction. Like 2 by 5 is there. If you multiply 2, then denominator is 10. So 4 by 10. So 4 by 10, 7 by 10 we can identify as like fraction. If the denominators are possible, like we can convert into like fractions. So proper, improper, mixed, like, unlike. And next thing, decimal fractions. What is a decimal fraction? Sixth one, right? So what is meant by decimal fraction? So there is a decimal number. So decimal is separated with a decimal point. So this one we will read it as whole part. In the decimal we call it as whole part, and this is decimals. So how many digits will be the decimals, and this is decimal point separated with a decimal point. So 0.2. But generally when we notice these integers, we notice that 0, minus 1, minus 2 like that, and 1, 2 like that. So if we know, if there is a question, how many numbers are there between any two numbers? So it is not about natural number, or simply the question is how many numbers exist between any two numbers, means the answer is there are infinite numbers. Why? Because we can start from 1.1, 1.2, 1. Like that, or else 1.01, 1.02, 1.0, or else 1.001, 1.002, or else 1.0, like that. So many infinite numbers are there between any two numbers, right? So here each number we can representing in the form of a decimal. Each number we are representing in the form of a decimal. So now decimal fraction. So just now we noticed like an introduction of I used, right? So of, how can we notice of? Suppose you are while we are purchasing some vegetables or anything in the market. There the weighing machine is showing like 2.5 kg means 2.5 like that, 3.75 like that. So it won't show like half kg, 3.5 like 2, and so it will show with a decimal point, right? So like 1 by 2, how can we represent? It is half only. So we can represent, how can we convert this fraction into decimal? How can we convert? So in the first video already we discussed, right? So 1 by 2 to convert into decimal, if the denominator is 0, we can write directly, right? Suppose 1 by 10 is there, directly we can write 0.1, but here denominator is not 10. So we have to make it 10. If it is possible, we have to make it 10. So into 5, then it will be 5 by 10. Then we can read it as 0.5, right? So in the one half we can say it as 0.5. So like this conversion. So decimal fraction which are in the form of a decimal, the decimal can be converted like 2.3. So we can convert it as, first as it is number we have to write denominator, decimal point after how many digits are there? 1. So we should keep 10. Like 2.32. Now it is 232 by 100, right? Next 14.7 like this. So totally we have to write the number 1, 2, 3 after decimal point 3. So we have to keep 3 zeros, right? So this is about the conversion of a decimal into fraction, like simply decimal fractions. So now we will see how to convert a fraction into decimal. So just now we discussed, right? Fraction into decimal, decimal into fraction. Let us discuss once again briefly. So fraction is given like this. Suppose 2 by 5. And another thing, suppose 2 by 3. So now we want to convert this fraction into decimal. So if the denominator is in the form of 10 or 100 or 1000, we know, right? So if it is not in the form of 10, 100, we can make it into 10 by multiplying with a suitable number, right? So 5 into 2. So we will get 4 by 10. So here 1 0. So we will get, so as it is number means it is 4. So after only 1 0. So after one decimal, we should keep after one digit. So 0.4. Suppose another example like 5 by 100 is there. Then this one can be read as 5 as it is. So 1, 2, 2 zeros. So only one digit. So 1 and another 0 we should keep, and then we have to write 0.05. Okay. And next similarly suppose 7 by 1000. Then how can we write? So first number and next 1, 2, 3. So there is one digit. So 1, 2, 3 and then keep decimal point. Means 0.007. So if the decimal is adjustable, we can. If it is not adjustable, then what we have to do? So like 2 by 3, 4 by 7 like this. Then we should do basic division, right? So 3 is divided. Like 2 we have to divide by 3. So it is a small number, right? So we can't find a number less than 3 in the 3 table. So we have to keep 0 point. Then we should keep 0 here, right? Now we have to observe 3 6 are 18. So 10 minus 8. So subtraction 2. So again decimal point is there. We can keep one more digit. So here same thing will be repeated. So here after the subtraction we will get 2. So 0.666 it will, the answer is only 0.6661. So we can write it as simply 0 point. If the same digit is repeating many times, so simply we can keep bar. So that is one thing. Okay. If the digit is not repeating, another question let us see. Like 4 by, instead of 5 we will take another number. 6 let us take, okay. So we have to do the basic division, right? So 0 point we should keep and keep 0. Then less than, so we in 6 table, we know division, right? 6 7s are 42, so 6 6 are 36. So subtraction 4, again decimal point is there. So again we are getting same thing, right? Here also we will get 0.6 bar. Let us take another question. Not 5, we will take another thing, right? Some 9 let us take, okay? 9 and 7. So 0 point you keep 0. So 9 8 is 72. So 9 7s are 63. We are getting a number using basic division. So let us take a number 3 by 4. Then we have to observe 4 and 3. So we have to keep 0 point and then keep 0. 4 7s are 28. Now the remainder is, so 2. So here 2 is there, again point is there. So we should keep one more 0. So 4 5s are 20. So we got the remainder 0. So 3 by 4 fraction can be converted as 0.75. Okay, if the same digit is repeating, we can use the bar symbol or else basic division. Now, fraction to decimal over. Now, decimal to fraction. Decimal to fraction, if it is in the form 0.2, already we discussed, right? 2 by 10. Like there is a number. Like this it is given. Then again, same number we should write. denominator 1, 2, 3. So 1, 2, 3, 3 zeros. So this is simply how to convert a fraction to decimal and decimal to fraction, right? So about fractions, in that after that what to discuss LCM and HCF. So before going to LCM and HCF, let us see first addition of fractions. How we will do generally addition of fractions. So let us see addition of fractions. So we have seen different types of fractions, right? Like first I am writing 2 by 5 plus 7 by 5. So which type of fractions are these? We notice the denominators are same. So these are like fractions. So if the denominators are same, means like fractions addition means, so denominator as it is we have to write. We have to simply add the numerator. So 2 plus 7, which is 9 by 5. Okay. Now unlike fraction. So unlike fraction means the denominators are different. Suppose 3 by 7 and 7 by 14. Right? Now the denominators are different. But in some case, we can make the denominators equal. Some examples see. So this is, we can convert the unlike fractions into like fractions if the denominators are same multiples. So 7, what are the multiples of 7? 7, 14, 21, like that, right? So here one multiple is there already. So if the one of the multiple is there, we can make the other fraction also same multiple in the denominator. Then this fraction becomes what? 6 by 3 2s are 6, 7 2s are 14. Again 7 by 14. Now the denominator is same. So we can do as it is like fractions. Now the denominators are different here. Here we notice the denominators are different and we can't make the denominators by taking simply multiples like previous question, right? 7 multiple is 14. So here 14 is there. We can written directly. But here 7 is different, 5 is different. In that case, what should we do? So in that case, we should take least common multiple. So that is only LCM. So least common multiple of those two numbers we should take. For 7, what are multiples? 7, 14, 21, and for 5, so on, right? So 5, 10, 15, so on. If the two numbers are complete, there is no common factor. So there is no other choice. We have to take simply the product. 7 5s are 35. Like if you are doing continuously, 7 3s are 21, 7 4s are 28, 7 5s are 35. For 5, up to 3 I have written. 5 4s are 20, 5 5s are 25, 5 6s are 30, 5 7s are 35, right? So we have to take the least common multiple. When onwards we can observe any common multiple is there. So before there is no common. So we notice 35 as the common multiple. So that is only least among all those. Least. So the remaining also multiples will be there. But among all multiples we should take least common multiple. So now here what we have chosen the question 2 by 7 plus 3 by 5. Now we should do addition of these two fractions. Now we got the LCM as 35. Now we have to make the denominator equal by taking the LCM. So now we got LCM how much? 35. Now we have to make the LCM in both the denominators. So 2 by 7. So how can we make the denominator 35? Here it is 7, but here we got 35. Means this 35 should be there in two denominators. So how can we make? So if 7 is multiplied by 5, then we can get 35. If 5 is multiplied by 7, then here we get 35. Right? So we have to notice that number by making equal same denominators. Right? Now we got 5 2s are 10 by 35 and 3 7s are 21 by 35. Now denominators are equal. So now we can do the direct addition by adding simply 10 plus 21 by 35. So which is 31 by 35. So that's why we are taking LCM. So LCM we are taking to simply make the denominators equal. So to make the denominators equal, we are using the concept LCM, least common multiple. So LCM, we will discuss how to find LCM. Okay, so addition of fractions. Similarly, subtraction also we can do. Subtractions. So same thing. If the denominators are same, means like fractions. So directly we can do the numerators by taking numerators like 7 minus 3 and denominator is equal, so 7 minus 3, 4 by 10, right? So here 4 by 10, the fraction can be converted into simplest form or lowest form. Simplest form or lowest form by taking a common multiple. Like here, if we divide the same number, if the number is divided by same, like 4 by 10. So two numbers are divided with the same number, like with 2. If you are dividing with 2, so 2 2s are 4 and again 5. So the same number can be cancelled, right? So this is only cancellation generally we are using. Suppose 15 by 25. So 5 we can cancel. 5 3s are 5 5s are. So which is 3 by. This one we cannot simplify again. So that is only least form or simplest form or lowest form. So after doing the subtraction or addition, we can convert into least form or simplest form also. So in the addition of fractions, for unlike fractions only, we are using the concept LCM, right? So let us see once again what is LCM. So what is LCM? Least common multiple. Least common multiple. So least common multiple. So every time we can't write all the multiples. Suppose just now we discussed the 3 by 7 and 4 by 5. What we did here, all multiples of 7 I have taken and all multiples of 5 I have taken. We chosen the least one. So every time it is like it takes a lot of time. So it is very taking the multiples. All multiples is difficult. So it is time taken, right? So there are two methods to find the LCM. Right? To find the LCM there are two methods. So one is prime factorization method. One is prime factorization method. And second thing is long division method. So division method we can use long division method. So what is prime factorization method? Suppose let us take an example. Find LCM of 12 and 20. So there are only two numbers. So generally what we are writing, all multiples of 12, 20, all multiples of 20, like by starting like that, choosing the least one, we are finding a least common. But now what is prime factorization? So no need to write all the multiples. So prime factorization. So this number we should express in the form of prime numbers. So 12 with 2 you have to divide. So 2 6 are 12. Again with a prime number, if with 2, if it can be cancelled with 2, again 2 3s. So until you reach the 1. So 2, again this 3 cannot be cancelled by 2. So we have to do with 3. So 3 ones. Until reach 1 here we have to do this process. So 12 can be written as 2 into 3. Until reach the 1 we should do. Okay. So 12 can be written as 2 into 3. And next similarly for 20 also we should do. So for 20. So for 20 also again prime factors. For 20 also again prime factors. Start some prime numbers. So 2 we have to start. So 2 tens. Again 10 can be cancelled by 2. If it is not cancelled then we should go to the next prime number. 2 after 3. So again this 2 can be cancelled. So 2 5s are. Again 5 cannot be cancelled by 2. And next 3. So 3 also not cancelled. So we have to cancel by 5 only. So 5 ones. So finally until reaching the 1 we should do the process. So then 20 can be written as 2 into 5. Right? So now these are the prime factors we got. This number we expressed as 2 into 3 and 20 we written as. Now how to find the LCM for this? So you have to remember one thing. LCM and HCF. Here only we will discuss simply LCM and HCF. Both also we will discuss. Why? Because if we compare and learn we can remember easily. See LCM what? HCF what? Same question. HCF highest common factors. Okay, so we'll discuss briefly, but identification is important. So HCF means we should take highest. The word is highest. We should take least common. Like what are the least? Like 2. How many times it is there here? 2 times. Here also 2. How many times it is there? 2 times. So commonly least it is 2 square. 2 times it is there. And remain there is no other number. So only this is only answer. Like 2 square means 4 is the HCF. That's it. So highest means opposite word we should take, like least common powers. Least common powers, you remember. Least common power, like 2 times is there, here 2. 3 times opposite is there. Then 2 times only we should take. Okay. LCM what? Least opposite word high means highest times how many times highest it is there? 2 times only, 2 times. Again all factors we should consider. So 3 how many times highest it is there? Only 1 time. So 1. Again 5 how many times highestly it is there? 1 time. So this is LCM. So what is LCM? 2 times is there, means 2 into 2. So 4. 4 3s are 12. 12 5s are 60. So LCM is 60. HCF is 4. Okay. So let us verify that LCM 60. So 12 you want to verify our answer is right or wrong. So what are the factors of 12? Sorry, what are the multiples? Least common multiple. We are verifying LCM, right? So 12 multiples you write. 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 fives are 60, 72, so on like that. Now 20 multiples you write. So 20 ones are 20, 22s are 40, 60, 80. Already we identify a common number, right? So what is that? So we identified that least common multiple is 60. So here multiples of 12 and multiples of 20, among all those least multiple is 60. So which is LCM. So we have seen in the long division method and prime factorization method, right? Now let us discuss about HCF. HCF means highest common factor, or another name is what? GCD. So greatest common divisor or highest common factor. So again we will discuss first by prime factorization method. So directly go with some examples. Suppose the number can be expressed 2 cube, 5 square, 7 power 5. And some another number x is equals, another number, so y equals to some 2 power 5, here some 12, here some 7 and 7 cube. Okay, so how to find the HCF? So LCM what we have taken? All factors with highest powers. HCF what should we take? Highest, opposite word what is it? Least. So we should take least common powers. So common power and least. So this is like common factor. So common factor and least power. So common factor, what is common factor here? 2 is a common factor and least power. So what is least power here? 3. So least power we should take. Again common factor is what? 5 and least power is how much? 7. Again common factor is what? 7 and least power is what? 3. So whenever highest common factor is there, least you have to remember. Okay, so simply you can remember LCM and HCF in the prime factorization method. LCM means all factors with highest powers. All factors with highest powers for LCM. For HCF means common factors with least powers. Okay, so common factor and least power. Common factor here and least power, that is HCF. LCM, all factors and highest power we considered. Okay, so this is about simply LCM and HCF. So addition and subtractions of fractions we discussed, right? Now let us see multiplication of fractions. So how we have to do multiplications and division of fractions. Okay, so first one, so generally multiplication how we will do, suppose 2 into 3. So 2 into 3 which is 6. But what is the denominator here? There is nothing, means we can write as 1, right? So 2 by 1 into 3 by 1, which is 2 into 3 numerator, 1 into 1, 1, so which is 6. Now there is a number in the numerator like 2 by 7 into some 14 by 12. Then in that case, again numerator into numerator, we can multiply denominator into denominator. So 28 and 12 sevens are 84. Again this fraction we should convert into least form. So 2 14s and 2 42s. Again we can cancel 2 7s, 2 21s. Still we can cancel 7 1s, 7 3s. So same number. So we got simply 1 by 3, right? So without multiplying directly also we can do the same question. Like how? So numerator, denominator, this numerator, this denominator. Any two we can take, but one number in the numerator, one number in the denominator. We should cancel with the same number. So 2 1s, 2 6, 7 1s, 7 2s. Again here numerator, denominator we got 2 by 6. Again 2 1s, 2 3s. So we got answer as 1 by 3. This is about multiplication of fractions. Now divisions. Generally division 8 by divided by 2. How we will do? So we can write it as 8 by 2, which is 4. Now there is a number 8 by 5 divided by 16 by 10. Okay, now denominators are there. Here denominator not there, directly we can keep 1 means 8 by 2, 4. Now instead of this division symbol, we have to keep 8 by 5 into and 16 by 10 becomes 10 by 16. That's it. Okay. So generally how can we write 8 by 5 by 16 by 10 means this one we have to cancel. So after writing the next step 8 by 5 symbol will be changed as into and 16 by 10 becomes 10 by 16. Now as it is like multiplication how we cancelled. So with 2 4s, 2 8s, 5 1s, 5 2s. Still can we cancel these two also 2 1s, 2 4s. So 4 and 4 will get cancelled. So finally answer is 1. So both are equal, right? We can multiply, we can 2 8s, 2 5, 8 by 5, 8 by 5 means we get the answer as 1. So this is about division of fractions. Multiplication we got means division also simple. So this is about division, multiplication, right? Now let us see BODMAS rule. So BODMAS rule, let us see. So V for nuclear or bar and B for brackets and O for off and D for division and M for multiplication and A for addition and S for subtraction. So what is this rule? So let us take a question. So example, sum 25 into 80 minus 10 bar plus some question is there. So here we can notice into, plus, minus and bar. So in this case first preference we should give for bar. So here it is bar. So 80 minus 10 is how much? It is 70. Next remaining it is what? Next preference what? Brackets. There are no brackets. So next is what? Off. There is no off. Next division. Division not there. Next what is there? Multiplication. So here multiplication is there. So we have to multiply 25 zeros and here 14 plus 3 175 plus 7 minus 5. Again next what here? Addition, after that subtraction. So addition means this one. So 57 minus 5. So finally answer is 175. So using the preference, we should give the preference according to the symbol. So brackets also again they have to follow the order. Curly brackets, square brackets and open brackets or parentheses. Okay, so these are the rules you should follow for doing any calculation. So this is about number system which is useful for paper 1. Okay.